Okay, so this video is going to be about a quicker way to do the chain rule. So, well, why do we need a quicker way to do the chain rule? Well, we need it because one of the biggest dilemmas in life, or at least in my life, is that I don't have time to do the things that I want. And I'm sure, well, I do have time to do some things that I want, but I don't have time to do everything that I want to do. And I'm sure you're faced with a similar problem. So, what if I told you that I had a way where you could create time out of thin air? Well, this is that way, because the less time you spend on doing things like the chain rule, the more time you can spend with your cat, or with your dog, or, listening to music, or traveling the world, or studying for other subjects. So yeah, the quick chain rule is just there to save you some time. So, let's do this question the long way first. So as you can see, we have a function within another function, and that tells us that we can use a chain rule. So one function is this, 2x squared plus 5x, and that is within another function, which is something cubed. So it's a function within another function, or a composite function. Okay, so let's do this the long way. The long way. Okay. So the way we would do this is we would say, let u be whatever the inside function is. So the inside function is 2x squared plus 5x. Actually, one thing I should have done when I was writing this question to make it a bit easier notationally is I should have made this equal to y instead of f of x, but it doesn't really matter, you can do it either way. And if something is in terms of f of x, you can always say let y equal f of x. That's valid. You can let y equal that if you don't want to deal with the function notation. So that's what I've done here. I've let that equal to y as well. So u is equal to that. Then we know two things following on from that statement. We know that y is equal to u cubed, and therefore dy du, derivative of y with respect to u, is 3u squared, just from your power rules. Okay? And we know another thing. The other thing we know is that du dx, from here, we can calculate that to be, so the 2 comes out the front, that becomes 4x plus 5. Okay. And we know what the chain rule is. The chain rule is, we need to find dy dx, and we have dy du, and du dx. So that's the chain rule. I should have actually done these in the separate colors, but that's okay. So dy du, let's sub that in. That's 3u squared multiplied by du dx, which is 4x plus 5. I'm just going to put a bracket around the whole thing, just so that I don't confuse myself. So it's these two things multiplied together. Okay? Before we move on, let's have a look at what these things are. Okay, so, well, this orange thing over here is just the derivative of this outside bit. It is the derivative of something cubed if that something was just a variable. If we name this variable u, then the first term is just the derivative of u cubed. So for this orange part here, all we're doing is we're ignoring whatever's in the brackets and just taking the derivative of that as if nothing was in the brackets, or as if whatever was in the brackets was just one letter. So it's just the derivative of that, which is 3u squared. The derivative of something cubed is 3 times that something squared. Yep. And what about the green term here? Well, the green term here is just the derivative of whatever's inside. So the derivative of 2x squared plus 5x is 4x plus 5. So that's basically what we're doing when we're doing the chain rule, is we're taking the derivative of the inside, which is 4x plus 5, times the derivative of the outside, pretending that nothing is inside. So the derivative of something cubed is 3 to that something squared. And of course, the next step would be just to sub in what u is in terms of x. So that is, 3 U is 2x squared plus 5x, and then multiplied by 4x plus 5. Yep, so the quick way to do the chain rule is just to recognize that whenever you have a chain rule problem, if you have f of x, then the derivative of f of x will always just be the derivative of this bit, pretending that the bracket didn't exist, pretending that we're just looking at the letter, multiplied by the derivative of whatever we just covered. So cover what's inside with your thumb, take the derivative, and then look at what you were hiding under your thumb, and then take the derivative of that, and then multiply the two things together. Okay, let's have a look at a few examples to help solidify this understanding. Okay, here we have f of x is equal to 7x cubed minus 5 raised to the power 6. Okay, I'm going to do this the quick way. So, the quick way is easy. I only need one line. So I just write f dashed of x is equal to, okay, well, let me put a thumb over whatever's on the inside. So we have something raised to the power 6. So what's the derivative of something raised to the power 6? Okay, well, the 6 will go out the front, so we will have a 6 here. So 6 will go out the front, and then whatever that something is, that'll remain there, so we still have some brackets there. And then the power will be reduced by 1. So we have a 5 there. So the derivative of something to the power 6 is 6 times something to the power 5. Yep, and let's ignore what's in the brackets for now. And then we multiply it by, we lift our thumb and we find the derivative of whatever was underneath our thumb. So the derivative of 7x cubed minus 5 is just 21x squared. Yep, because the 3 comes out the front, so that becomes 21. And then the power reduces by 1. And then the derivative of negative 5 is just 0, so you could write minus 0 here, but it's not really needed. And of course, what we just took off our thumb, so now we can replace whatever was inside the brackets. So this will be 7x cubed minus 5. And just cleaning it up a bit and removing all the colors. So what is 6 times 21? I'm just going to do that on the side because I don't want to make a mistake. 6, 12, 126. That was pretty easy. I shouldn't have needed to calculate that, but that's okay. 126x squared times 7x cubed minus 5 to the power 5. So that is the derivative, f dash of x. Okay? Let's do one more example. This is a bit trickier. You can tackle all sorts of examples with this thing, and the more you practice, the quicker you'll get. And if you're not sure, just do it the long way to make sure you get the same answer. So here, in fact, I'll do that in this for this question. I'll do it the short way, then I'll do it the long way just to show that it's the same answer. But hopefully you'll be able to understand that just by looking at the short way. So we put our thumb over whatever is the inside function. Yep. So what's the derivative of something to the power 5? Well, it is 5 times something all to the power 4. So, dy dx would be 5 times something to the power 4. And we're not done yet. So we remove our thumb and fill in what's inside. So it was 5t cubed minus t squared plus 2t. And we know that this whole thing is going to be multiplied by the derivative of whatever we put our thumb over. So we need to find the derivative of that and multiply this by that. So what's the derivative of 5t cubed minus t squared plus 2t? Well, that is just 15t squared minus 2t plus 2. Yep, that's it. So there's our answer. Our answer is 15t squared minus 2t plus 2 times 5t cubed minus t squared plus 2t power 4. Yeah, here I've just brought this to the front and put this behind. Yeah, you could probably even leave it like that. So that's a short way. And just to confirm that we get the same answer, I'll do it the long way. Remember, the short way and the long way is, pretty much just the same. The short way comes from the long way. So the long way would be let u equal, so remember that is our original question, so let u equal whatever's inside. So 5t cubed minus t squared plus 2t. Therefore, y is equal to u to the power 5. So dy du would be 5u to the power 4. And du dx, du dt, because we have t's here, not x's. So du dt would be, I made a mistake there. That shouldn't be dy dx, that should be dy dt. Because we're not dealing with x's here, we're dealing with t's and y's. Okay, so what's du dt? So derivative of that is just 15t squared minus 2t plus 2. Now once again, you will notice that this is exactly what we have here. We just omitted this step. So 5u to the power 4 is this. 5u to the power 4 is the derivative of the outside function, pretending that we had nothing inside. And we're multiplying that by this, which is the green bit here, which is just the derivative of the inside function, whatever we put our thumb over. Yep. And of course, just finishing off here, dy dt is dy du times du dt, which is 5 to the power u4, and u is just that, so I'm going to sub that in. Oops, sorry, you can't see. So 5u to the power 4, so 5t cubed minus t squared plus 2t, which is u to the power 4, multiplied by 15t squared minus 2t plus 2. There you go. So as you can see, same thing in both these cases. This barely fits on the screen, but I think you can see. There's the first one, there's the second one, and it's exactly the same. So the short way and the long way will give you the same answer, but the short way gives you more time to play with your cat. Yep, and that's pretty much it. So one thing that I think you should know is if the question says use calculus, we're talking about VCE exams here, so if it says use calculus, then you have to do it the long way. You have to, and I think it will also be better just to say in brackets or somewhere chain rule. Just say that you're using the chain rule, because they want to see explicitly what rule you're using if it says use calculus. However, if it doesn't say use calculus, if it just says find the derivative, if it's only just 1 mark, then you can use the short way. Or if it's part of a larger 4-mark question, and as part of that question, one of the things you have to do is find the derivative of something, then again you can use the short way. So the only time you'd have to use the long way is when they explicitly say use calculus when in the exams. So I hope you found that useful, and yeah, I will keep making a few more short clips like this that will hopefully improve your understanding on different topics. Okay, have a nice day.